Lesson 868, Animal Brains, Analyzing Bivariate Data. In this lesson, you'll create a scatter plot and draw a line to fit bivariate data and identify outliers that appear in the data. You'll also use associations between two variables to make predictions. We're going to continue today with some just developing our knowledge of scatter plots a little bit more. In your notebook, you're on page 87. And our learning goals for today start with being able to create a scatter plot, draw a line of fit to the data, and identify outliers. We'll talk about what those are in a moment. We'll also use associations to make predictions. All right. People often collect data to investigate possible associations between two numerical variables and use those connections to find and predict more values based on what they've seen so far. So here we have a scatter plot that shows two things, flight distances and flight times for a set of flights. And it looks like there's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 flights represented in these 10 dots. There's two dots that are kind of smushed together here. So on one axis, we're looking at each of these flights' distances in kilometers and each of these flights' times. So we have two pieces of data for each flight. So the first thing we're asked to do is sketch a line on the scatter plot that fits the data well. Now when we're sketching a line of fit, there's really two steps to doing this. First thing you want to do is do your best to kind of approximate the slope of the data. I know it's not in a perfect line, but you can kind of see the trend that the data is going. You can see what would be too steep or too shallow. So you just kind of want to wiggle around until you feel like you've got about the same slope as you see in the data there. And then once you've got that slope, you're going to scooch it so that about half of those data values fall above your line and half fall below. So it looks like these fall in a pretty nice little line there. But those are your two steps. Approximate the slope and then slide until you have about half of the dots above and half below. Then we're then asked to add a point to the scatter plot that shows a 1,500 kilometer flight with a flight time of 2 hours. So let's see if we can find that. There's 1,500 kilometers and 2 hours. That's what we're asked to add here. So that coordinate tells me two pieces of information. The flight is 1,500 kilometers, and it takes 2 hours to make that flight time. The third thing we're asked to do is add an outlier to the scatter plot. So we have a lot of points, or a lot of planes that really fall in line. Anything that's far above or far below this line, far away from the other data points, is going to be called an outlier. So I'm going to do an outlier in blue here. As long as your outlier doesn't fall in line with these others, you did it right. I am going to put a point right there at the point 1004. So my flight distance is 1,000 kilometers, and it's 4 hours. And to explain why this point is an outlier, well, first of all, it's far away from the line of fit. And secondly, this flight that's 1,000 kilometers, looks like it takes much longer than it should. A flight of that distance should only take a little under 2 hours, but this one takes 4. I'd hate to be on this flight. Let's see, how can I say this? The time, 4 hours, is much longer than we would predict. Oops, it's a P. For a 1,000 kilometer flight. Oops. According to our scatter plot, a 1,000 kilometer flight should not take that long. So we've already got a lot of information that we can talk about as we analyze this data. Let's move on. You're asked to describe the association between flight distance and flight time. And when we're describing associations, we're talking about positive associations, negative associations, or no association at all. And what I'm noticing is that as the flight distance increases, the flight time also increases. So it's got a positive association. As the flight distance increases, flight time tends to increase. The flight distance was the variable on the x-axis, and when it increased, the flight time, which is the variable on the y-axis, also increased. So, because of that, this is a positive association. And the final thing we're going to do is use our model to predict the y value. So y value would be the flight time of a point on this scatter plot with an x value of 2,000. Let's do this in orange here. So I have a flight that is 2,000 kilometers. Here's my x value. And to make a prediction about that y value, I'm going to come up to that line of fit. That's what it's for, making predictions. So it looks like my y value would be a little under 3. I'm going to say 2.75. What does this point tell you about the flight distance and the flight time of the airplane? Well, it tells me that the flight distance is 2,000 kilometers, and the flight time, I would expect that to be about 2.75 hours. A 2,000 kilometer flight would take about 2.75 hours. That's what I could predict. And finally, what are some things that are important to remember when analyzing a scatter plot? Well, look for positive and negative associations. A positive association would mean that as the x values increased, the y values would also increase. And that's what happened up here with our flight data. As the flight distance increased, the flight time also increased. And it has like a positive slope on that line of fit. If it were negative, as the x value increased, the y value would decrease. And it would look like it had a negative slope. So that's just a little bit more practice with scatter plots and how we can use them to analyze data.